This is the next lecture in the series, and in this lecture I'll be discussing about the different elements of the electrical circuit. Like what we discussed was about the passive elements in the previous and the active elements. So the active elements were the ones which were the current sources and the voltage sources, which were supplying the energy to the circuit. Again, the passive elements were the resistance, inductors, capacitors, etc. of the circuit. So these are the three main elements of any electrical circuits. There are other elements, but like the semiconducting diodes, etc., which will be related to the electronic circuits, which are we will not discuss much. Anyway, the if the symbol of the resistance can be as shown in the as shown here. So there will be cross lines as shown, and it's written as the resistance, and the current flowing can be shown by the arrow. So the direction of the current will be mostly from the positive side to the negative side. So this is the direction of the voltage which will be across the resistor. So it will be all the from the direction of the current, you can say that the voltage will be from the positive side, or the voltage drop across the resistor can be written as the from the positive to the negative side in the sign convention. Again, if you talk of a simple conductor like a copper wire as shown here, it will be having many atoms inside it, and each of these atoms, like any atom, will be having a proton, and it will be also having something called a neutron, and this will be the nucleus. And there will be free electrons, so the electrons will be always free to move inside the conductor, and whenever any electrical uh, voltage is supplied, the electrons will be attracted towards, since electrons have a negative charge, it will be attracted towards the positive terminal, and from the negative terminal again the electrons will be pushed outside. So in such a way there will be the flow of the electron happening in this direction as shown, and again the flow of the current will happen again in the opposite direction. That is a sign convention which is used. So the resistance can also be said as an opposition to flow of the current. So resistance is a opposition to flow of the current, and when in real scenario, if you consider any wire or any winding will have some kind of resistance associated with it, and whenever the current will flow through that coil or wire, the resistance, whenever if you consider about the DC case, whenever the current will be flowing, the resistance will be dissipated as heat loss, or the resistance, the loss due to resistance will always happen in form of a heat. So you can you see the simple heater which you use in your room or in your house to heat the water, or heat the air in your house, like a room heater, etc. Such kind of devices are simple coils through which current is passed, and when current is passed, energy is dissipated in the resistor as in the form of a heat. So the equation of the resistance can be written as R is equal to V divided by I. This is in direct relation to the voltage and the current flowing in any circuit, and this is also known as Ohm's law for the circuit. Again, the next important element in any circuit is the capacitance. So the capacitance is an element which is capable of storing energy under the electrical field. So whenever there will be a electrical field, this capacitance will come into picture, and the capacitance will only come in picture for the AC circuits. It will not come in picture for the DC circuit, because capacitance will be related to the frequency of the circuit, which will be necessary for the production of the electric field. So if you consider that any two field of metal like an aluminium is separated by some insulating medium, usually this can be some insulating medium like a mica, or it can be simple air, and a voltage is applied across the two plates which are separated, then there will be a capacitance which will be formed on this between these two plates, and like there will be some amount of charges which will be formed on both these sides, and the charges will try to move from one plate to the other, and like there is a opposition in the conductor that this is a conductor, so the opposition in the conductor is known as resistance, while the opposition in the electric field which will be formed in this between these two plates is known as some kind of capacitance effect. And there will be always some kind of charge which will be stored inside this capacitance, and the equation of the charge of any capacitance, suppose there is a capacitance you can buy in the market. Suppose you have a capacitance of 10 Faraday or something like that, then there will be uh, and if you are supplying a voltage, then there will be a charge which will be stored in that capacitor. So even after you remove this voltage, this amount of charge which charge will be available in this capacitor, and this will be able to supply the energy to the circuit, or this energy to some other circuit when a complete circuit is formed. Suppose you are removing this voltage, and if you are connecting a resistance after some time, then the energy stored in the capacitor will flow as current in this resistor. So that kind of scenario is possible, and the energy stored in any kind of capacitor is known as Wc is equal to half Cv square. So capacitor is one more element, so I will not discuss into much detail about capacitor and the equation in this lecture. While I am covering the AC circuits, I will go into more detail. So if so after some days I will be uploading, or during the next few days I will be uploading about the AC circuits and the AC theory. So at that time you can refer to that lecture to know more about the capacitor. Again, coming to the next important element of the electrical circuit is the inductance. So if you are having a simple core, suppose a simple core of aluminium or any other metal is wound by, suppose, a wire, which is, this is a core of aluminium, and this is wound by wire of copper, and it is supplied by AC current. So there will be alternating current which will be flowing through this circuit. So this alternating current will set up a field across field everywhere across the wires, and this field will cause an effect like the resistance will oppose the flow of the current. The inductance will be causing the effect of opposing the field which is produced as a result of the flow of the current. So that is somewhere like a loss which is happening in the AC circuits can be in form of inductance and the capacitance, due to electric field in case of capacitance and magnetic field in case of inductance. So the inductance can be defined as a L is equal to V di by dt, where di by dt is the rate of change of current which is happening through the coil, and this is known as the self inductance. And if I am bringing some other coil nearby, there due to this field it will link, and some inductance will also be induced in this, which will also be able to supply voltage across this. So this phenomena is known as mutual inductance and is used in transformers. So you would have seen the transformer full series of lecture about transformer I have already uploaded, so you can go through that theory of those lectures of transformer, and you can understand that. Again, transformer works on the same principle of mutual induction. This is given by Faraday's law of inductance, and the energy stored in the inductor will be given as half Li square, where I is the current flowing through the circuit. So that's all about discussing the three important elements, that is the resistance, inductance and capacitance. Again, in the next lectures we will see how to solve circuits and the different kinds of network theorems, etc. So this is not a full course about the AC theory, so this is just a or the circuit theory, as most of these things will be covered in courses or subjects known as basic electrical engineering. So that's all. If you like this video, please do subscribe.